Can you guys see my screen?
Yes, sir, I can see it.
Okay, that's nice. Now there are numerous databases where you can get drugs, where you can get compounds, where you can get as many molecules as you want. And today I'm going to be treating about 3 to 4 of them, 3 of them today. And we are going to look at each of them individually, and I will explain some things to you from them. The first thing, probably you can just go to your browser, type Pubchem, Pubchem, Pubchem. I believe you can see my screen, right? Please, I want to be hearing responses from you guys.
Yes, I can see it, sir. Yes, sir.
Okay, Pubchem. Then you press enter. Pubchem, you can now once you press enter, you will see Pubchem, probably the first one. Pubchem is a database of compounds, of chemicals, of drugs, anything you can just name, and it's being sponsored by the National Institute of Health here in America. Is in fact is the world's largest field chemistry database of ligand, of compound. Whether if you are looking for a compound, okay, you want to see if a compound will work as a drug and you need the structure, just come to Pubchem, look for it. So just click on this Pubchem and you see, can you see my screen very well? It says explore chemistry, quickly find chemical information from authoritative sources. Authoritative sources means they are from scientifically proven sources, not just anyhow source. And I also want to point out to this: when we are working with drug discovery and we want to use artificial intelligence, it is important you identify the chemical structure that you want to work with. If you remember when I was explaining the ligand base and the structure base yesterday, you have to identify the ligand structure, you have to identify the protein structure. So for you to get ligand structure, Pubchem is one of the databases that you use to identify ligand structure. When we want to identify protein structure, we use what we call protein data bank. But we are not getting there now. We are in ligand because you guys are basically physical science. So I have to explain from the beginning, like I'm explaining to a beginner. So that's the case now. So for you to get the structure of a ligand, you have to first of all come to a database. And one of it, I will be talking about 3 of such databases for you that you can use, so that if one is not working, if you're not getting your compound, it's possible you don't get some compounds on Pubchem, then you can try another one, then you can try another one. Now, if peradventure you try all these 3 databases and you are not getting your compound, then I will show you how you can draw your own structure yourself. I'm going to show you that, how you can draw your own structure yourself. I hope you guys are getting me. Any question? Hello?
No, sir.
Are you guys following me?
Yes, sir.
Okay, please. I want you guys to follow me very well, so that I will understand where exactly if there's any challenge. So like I was explaining, the number 1 database we are going to talk about today is the Pubchem database. It's called Pubchem database. It's sponsored by National Library of Medicine, which is part of NIH and Parastatal. So now, can someone suggest a drug for me or a compound? Maybe there has been a drug that you have used in the past or anything. Just can someone suggest for me?
Aspirin.
Aspirin? Okay. So all you need to do is just come to this and type aspirin. Can you see? By the time I type it, it's giving me suggestion. So the first one is aspirin. Click on it. And you see, there are different This is aspirin. Click on it. Can you see aspirin? This is aspirin for you. And the first thing you see is the structure of aspirin. Because in drug design, you need the structure, especially the 2D and the 3D structure. Mostly the 3D structure. But if you are not getting 3D structure, you can make use of the 2D structure. So this is Pubchem. And this is aspirin, for example, that we are looking at. And if you look at this database, it's not only giving us information about aspirin, about the structure, it's also telling us about the safety level, the chemical safety of aspirin. And if you look at this, it says you can click on this. Let me click on open new tab. So on this hazard symbol, that I have here, I right click on it and I open a new tab, and it's giving me detail about information, the toxicity level of aspirin. Can you see? It says warning, harmful if swallowed, acute toxicity, oral, causes skin irritation, skin corrosion, irritation. So it gives you detailed info about about the drug that you are working with. And another thing is what we call molecular formula. How many of us know molecular formula? Probably matter, at least even though we are not in biological science, we took some science courses probably in the college or high school to give us information about it. Then it also give us synonymous names of aspirin. Is aspirin. Some can call it acetylsalicylic acid. Some can say 2-acetoxybenzoic acid. Some can say 2-acetoxybenzoic acid, and many more. Many more. Are you getting me? I'm just trying to let you know how you can get information about drug. Even if a drug is being prescribed to you in the hospital, you can as well come to this place and type the name of the drug in that database. It will give you the information. Then it also gives us some chemical and physical properties of aspirin. The molecular weight is 108.16. The X log P. This X log P means it's talking about the level of solubility of lipophilicity. How soluble is aspirin in lipid environment? Hydrogen bond donor, hydrogen bond acceptor, rotatable hydrogen bond from the structure. I know this you may not understand now, but by the time we progress, you will understand some of these things. So it also gives us some experimental property. The physical property of aspirin. Are you getting me? It appears as odorless white crystal or crystalline powder with a slightly bitter taste. I think, okay, and are you the one that gave us the example of aspirin?
I'm the one.
Yeah. Did you ever tasted aspirin before?
Oh, I'm sorry. I thought you were asking me if I tried aspirin before.
Have you tasted it before? I just want to confirm if you can remember the taste. It's slightly bitter, right?
Mm-hmm.
Or sweet?
No, it's not sweet.
Yeah. So this database will give you information about about any drug. For the purpose of drug design, the purpose of visiting databases is two. Purposes are two rather. The first one, to have information about a compound, like what you are deriving now. You can have, at least from this aspirin, we've had some information about the safety level. So it's not something you just go to the counter and take and you take orally. We have information about the chemical structure and the rest. That's one. The second thing in drug design, if you want to, for example, if you want to test if aspirin is going to cure a disease, maybe for example, SARS-CoV-2, for you to work with the artificial intelligence softwares you want to do, you need the structure of aspirin. And how do you get the structure of aspirin? You can come here and download this structure. that I showed this structure. You can come here and download the structure. This structure. And if you look at this chemical, this is a 2D, this is what we refer to as 2D structure. This is a 2D structure of aspirin. This is how aspirin looks like. You can see the benzene ring, the carboxylic acid, the carbanoid group, and everything. This is the structure of aspirin. Okay, so you download this structure and you use it further for your drug design. You can see the 3D structure. You can also download the 3D structure as well. You download the 3D structure of aspirin, and we also have the crystal structure, which most of the time we don't use crystal structure for computational for drug design. What we use mostly is 3D, and if there is no 3D, you can make use of 2D. A software will convert the 2D to 3D for you. Are you getting my point? So you have the IUPAC name. IUPAC name is International Union of Pure and Organic Chemistry. That is that's a kind of professional body of chemistry chemists. So we have the canonical smile. We have the ink smile. Canonical smile is another way of writing the structure of a compound. We have some other identifier. We have this is chemicalization society in America, chemical American society, something like that. We have Europe, so each of them has their own name for it. The European community also have a name. For us, this is the number. Sorry, this is the European community number for aspirin. This another one, the ICSC number. All these things you will understand later. We also have the United Nations. United Nations also have its own number. You know, these are drugs. They have to be well controlled, right? So those are the informations. And if you want to read more about it, you can go to Wikipedia. You can see all this information about a drug on Pubchem, and there are millions of compounds and drugs that if you want information about them, you don't need to stress yourself. Just come type the name there and to give you the information. Even if you are looking for research, maybe you are looking for research that has stuck, that you see the physical property is here, is 284 Fahrenheit at 760 mercury. That's the pressure, the melting point. Every information you want to think of about a drug. Solubility. Is it soluble in water? You say less than 1 milligram. So it's soluble in water to some extent. You have the density of the drug, the vapor pressure, everything, the lipid solubility, everything. The N's law. There are some different laws that governs drugs, like the Lipinski rules. We are still going to get there. I'm just trying to explain information you can get about a drug on database like this. We have the pKa, we have the dissociation constant. All this you may not understand, but with time you will get it. So every single detail about a drug is on this. For people in chemistry that are doing spectroscopy, this is the spectra for them. If they need information about this, about aspirin, you can see a lot of information. Mass spectrometry reading of aspirin. The GCMS information about aspirin is here. You are in engineering, you might probably don't understand this, but it's not with you. At least the basic thing is for you to understand the major ones. So and if you also want to see publications, journals that has worked on aspirin, we are just going there. You see different informations about aspirin. Just go there to tell you detailed information. Then if you want to buy this, in the lab we make use of chemicals. If for example we need aspirin to be used for an experiment, we can come to a vendor. These vendors, Sigma, Adrich, you can contact them and provide them this number. Just tell them I want this. They will sell it for you. If you want to have information about the drug and medication information, click on this. Can you see this is if you want information about aspirin, is pain, fever, and inflammatory. Is the regular tablet form, immediate release. Is indicated to relieve pain. Is a pain the liver, right? For fever, inflammation associated with many conditions, including flu, common cold, neck, back pain, dysmenorrhea, headache, toothache, pains, fractures, and you see, everything that you want to know about aspirin, you will get it under this. It has been segmented: the structure, the name, chemical and physical properties, spectral information, related record, chemical vendors, drug and medication formation, pharmacology and biochemistry. If you want to know about the pharmacology, is talking about how the drug exerts its therapeutic effect, how the drug is being metabolized to exert its therapeutic effect in the human body. You know, like I was telling you yesterday, you as engineering, civil engineering student, computer student, your own is you just take aspirin. You don't know what aspirin is doing in your system, right? But as a pharmacy student or as a biological science student, we know that okay, it's not just going there. Can you see effect on pain and fever? Aspirin disrupt the production of prostaglandin throughout the body by targeting carboxyoxygenase 1, that's COS1 and COS2. So in this case now, what aspirin is doing is to interact. These are the biological targets. If you remember that your drug must have a biological target that interacts with and bind with before it can exert its therapeutic effect. So in the case of aspirin, to relieve pain and fever, it interacts with cyclooxygenase 1, an enzyme, and cyclooxygenase 2, an enzyme. Do you get my point now? Any question before I proceed?
No, sir.
Hello, any question?
No, sir.
Okay. So can you see, I just show you for you to have information in this project, in this LEAP program. We want to learn about drug design using artificial intelligence tools for the next 3 to 4 weeks before we now go into developing our own software. And I said, if you want to do for this aspect, you have to get your ligand, the structure of the ligand. And one of the places where you can get structure of the ligand is Pubchem. Not just getting the information about the ligand, also not just getting the structure, you can also get more information about the ligand. And I said, if for example, I want to see the fact that aspirin has been used to treat pain and fever, it does not mean it does not mean we cannot try to see if it can cure SARS-CoV-2. We can use it to treat it to see if it can cure SARS-CoV-2. And if we want to do that, the first thing is to get the structure of aspirin, and we can come to Pubchem to get the structure of aspirin. Right. So prostaglandin are. So this is the pharmacology and biochemistry. So if you want to read more information, prostaglandin are potent irritating substances that have been shown to cause headache and pain. So most of the time when we have headaches, it is because prostaglandin is an hormone that is being released. And when prostaglandin is being released, there is headache, there is pain in the body. So what aspirin does is to go and inhibit these two drugs, these two biological targets, so that there won't be production of prostaglandin. You know, yesterday when I was explaining to you, I said when insulin is not working, there will be too much circulation of glucose in the body, and the person will be diabetic. But if you want glucose to reduce in the body, we have to look for a drug that will go and activate insulin so that insulin can reduce the level of glucose. In the case of aspirin, prostaglandin, when it is being produced enough in the body, it leads to pain and fever, right? Now, but what aspirin will do is, aspirin will go to the producer of prostaglandin, which are basically the cyclooxygenase 1 and oxygenase 2 enzyme, and inhibit their action. That these two biological targets, please stop producing prostaglandin so that my patient will no longer be having fever and headache. We call it as mechanism of action, or you can call it pharmacology or biochemistry of aspirin. So all these informations are present on the database. It's not just giving you the structure, it gives you a lot of information. You can just look at use and manufacturing. You see, you can see information about their use. Then another thing is, if you see a drug, this will also give you information. There are some drugs that they use in Europe that is not permitted in America. There are some drugs they use in America that is not permitted in Europe. So if you as an engineering student, someone just bring a drug to you, or someone just prescribe a drug to you, and you are like, what is this? Because if care is not taken, you can use the drug and it will lead to something dangerous. You can read about that drug, come to Pubchem. It will tell you, like this, in this case now, it is a human drug. That means it is used by human. By human. It is approved by a European medicine agency. Are you getting me? And I'm sure it is also approved by FDA. So if it is a drug that is not approved by FDA, it will tell you it's not approved by FDA. If it is a drug that is not approved by European medicine agency, it will tell you it is not approved. So these are just some of this information that you can get to know about the drug you want to take inside. Because let me tell you something, in toxicology, that's the study of poison is what they call toxicology. The belief is everything that we put in our mouth as human is a poison. Even ordinary water that you drink every day, if you take it in excess, it can be poisonous to your system. So it's always important to take note of what you are using into your system. Are you getting me? You should take note of what you are taking into your system. So you can read information about any drugs prescribed to you in the hospitals, in the clinics, or by any. You can read so that to get yourself familiarized, you can read. So there are countless number of information you can get here on the. Can you see? It's talking about the uses. It will tell you, can it be used by children? Can it be used by adults? All the information will be there for you to access. Do you get my point? It talks about consumers use, method of manufacturing, all those things. We don't need that. Safety and hazard. We've looked at that before. And you see the safety talks about the safety and hazard. Toxicity. How dangerous it is. Can you look at it? Look at the toxicity information. Later those acute oral LD value are reported to this. So which means anytime you take it above this, it is dangerous. In human, cat, and dog. And you see, it gives you information about what are the side effects of that particular drug. Are you getting my point? Then it's also gives you about this is hepatotoxicity. Hepato means liver. Like how can it be toxic to human liver? And let me tell you, every drug that we take is being metabolized by the human liver. So, and one of the things that they consider in drug discovery or drug design is how toxic is this compound that we are designing? Is this drug that we are designing to human liver? So you can see the information patent on long-term moderate to high dose aspirin frequently have elevations in serum ALT. This is an enzyme. So when you take it too much, what it means is it can disrupt the membrane of the liver, which could be another problem. So a whole lot of information about the drugs. You can look at the associated disorder and disease. What disease are associated with aspirin? You can see abdominal pain, aberrant fossil, abnormalities, drug-induced acid-base imbalance, acidosis. Many of them. Literatures means compounds in research that has been done on it. And if you look at this first one, survey reported medication changes among older adults during SARS-CoV-2 pandemic. So this one, I think they try to do a survey of medication changes among adults, and probably aspirin is part of it. So there are a lot of information you can read about it. And you see this one is COVID-19 associated irreversible cerebral vasoconstriction, syndrome successfully treated with linodipine and aspirin. Can you see this? Aspirin has been reported to be used for fever and pain, but from this study, there is a vasoconstriction in people with SARS-CoV-2, and they try to use aspirin on them, and they observed that aspirin can reverse this constriction that is happening in these people's life. Can you see? That is what we call drug repurpose. Aspirin is basically for fever and pain, but they try to use it on another type of patient, which is COVID-19 patient, and it will reverse that damage done in that aspect. So that's what we call drug repurposing. The fact that paracetamol is used for headache, or for this aspirin is used for fever and pain, it doesn't mean we cannot try it. You yourself can decide to use it for something else. And for example, remdesivir originally was designed for Ebola virus in Congo, but when SARS-CoV-2 COVID-19 came up, they have to test it on SARS-CoV-2 patients. And before they do that, they will have done some kind of computer-based drug assessment. That from what you are seeing on this system, it seems remdesivir could work well before they now take it further and test on SARS-CoV-2 COVID-19 patients. So those are the things. So from here you can read about other information about that particular drug of interest that you are looking at. So there are also a lot of informations on it. These are donors. You can also look at patent, how it was patent, all the patent that has been done on it, about molecular interaction. It interacts with these proteins, all these proteins and the rest. So a lot of information, a whole lot of info that you can get about your drug on database. Are you with me? Do you get it?
Yes, sir.
Okay. So you can see now.
Yes, sir.
Yeah. So let me lay this emphasis. The purpose of showing you this database, there are two purposes. The first one, when you have a drug or a ligand, a compound with you, you can read about that compound, detailed information about that compound, like we have seen for aspirin. That's one. The second purpose is when you are doing drug discovery, drug design, and you need a particular drug or a particular compound, you have to go and download the structure of that compound. And one of the places you can get the structure is Pubchem. It's one of the places where you can get the structure. So by the time we get into drug design, the molecular docking and the rest, I'm going to show you how to download and how you can test them on different biological targets to see whether they are going to work or not. So before we leave Pubchem, can we try another drug? Someone should suggest another drug for us. Can someone suggest another drug for us? Hello. Are you guys there?
Yes.
Yes.
So can someone should suggest another drug for us? Daniel? Brown? Or because
I've forgotten the name of the drug. It's
yeah,
like a malaria drug.
Okay. Let's try Lopinavir. Lopinavir is an HIV drug. It's a protease inhibitor. Can you see Lopinavir? Before we
I have
go
a
to
question.
another,
What is the taxonomy? Is that what it's saying?
taxonomy of what?
I saw when you typed it up, like that's one of the columns that came up. Like, what is a taxonomy?
This? Okay, well, I don't get you, please.
No, type in the drug, Lopinavir. Type that in again.
Lopi.
Okay, and you see right there, it says compound chain taxonomy.
Yeah, it's just talking. It's just general taxonomy of that name. But what we need is the compound. You know, there are we have compound, we have gene, the interact, and the taxonomy. You understand? So, but we are looking at the compound. This is the compound that we are interested with. Interested in. Yeah. So this is Lopinavir. Just click on it. And you can see, like I said, this Lopinavir, the information here is not giving us the 3D. we only have the 2D. So when we want to do our drug design, if we don't get, what we need is 3D. But if we are not getting 3D, we are going to use 2D. And I'm going to give us a software that will convert this 2D to 3D for us. And the same thing, can you see the chemical safety is an irritant and is health hazard. So just be careful to use. It's basically administered under the prescription of a physician. Chemical formula, Lopinavir, synonym, the other names, synonymous name, Calatrava, and the rest. Date it was created. The date this page was modified was about, I think it was this week, 26th of this month. But the page was created 2005. So you can read about Lopinavir. Lopinavir is an antiretroviral protease inhibitor drug used in combination with ritonavir in the therapy and prevention of human immunodeficiency virus, HIV infection, and the acquired immunodeficiency syndrome, AIDS. Lopinavir can cause transient and unusual asymptomatic elevation in serum and aminotransferase level. These are enzymes. You may not understand this as engineering students, but at least it gives you info about it. It also talks about the liver toxicity, how it can be toxic to the liver. Lopinavir is a peptidomimetic HIV protease inhibitor that retains activity against HIV protease with the valine 82 mutation. Lopinavir is less affected by binding of serum protein. So all these information you can get, and this is the structure of Lopinavir. Can you see this is a more complex structure than the first aspirin that we look at, isn't it? So this is the structure of Lopinavir. You can see the benzene ring. You can see the different functional groups on the protein. So these are the functional groups that will interact with the biological target to exert its antiviral activities. So just the same way, look at the name, and these are different names. Allopath name, we have the, and let me just, another thing that is very, very important in drug design, because we are going to do a lot of work on this, is this canonical smile. We can use canonical smile to predict a lot of things. And I have it, okay, I will tell you that later about a project I want us, we are going to work on a project together. And I'm going to give you a project that you are going to work with individually. So information about the chemical properties of Lopinavir, spectral information. This is for chemists. You may not need it. People that synthesize compounds. This information is for them. Chemical vendors, if you want to buy them, these are people that assess them. Drug medication information. Let's go to pharmacology and biochemistry. And this is what it does in the body. You know, when people with HIV take it, they get better. And what it does is it inhibits the activity of the HIV protease enzyme. HIV protease enzyme is one of the enzymes important in HIV replication, HIV life cycle. So it has a moderate duration of action, necessity ones. Lopinavir, like other proteases, has a propensity of participating in drug interactions. So there is what they call drug interactions and the rest. So we have the pharmacological classification. It's an HIV, is a protease inhibitor drugs, and some other. They also give us some level of absorption, distribution, and excretion. So a lot of information about any particular drug on this platform. So I think I've provided information to us regarding Pubchem. Do we have any question before we move to the next one?